Good afternoon, guys. It's me again. Now, this time I will make a video presentation about shifting of cargoes. Let's say you're docked alongside at berth, and you want to shift your cargo from, let's say, from hold number one to from hold number seven. I mean, from hold number seven going to hold number one. So let's do this, guys, and I'll show the presentation as well as the manual computation. So let's open the program. Okay. And let's say the problem is this one. So the problem says finding amount of weight to obtain a desired draft from given initial draft. So meaning, so this is your hold number 7 in the diagram, and this will be your hold number 1. From hold number 1, you're going to shift the cargo to hold number 1. So you take out some cargo here and you discharge it in hold number 1, or relocate it in hold number 1. So when you see LCG, meaning at the middle of the hold of the weight, and this will be your LCG, and all at the same time in hold number 1, in the middle of the hold will be your LCG. So from the center or the mid, you have the LCG measured from the mid to the center of the hold. Likewise, on hold number 7, from the mid part of your vessel is measured to the center of your weight of in hold number 9. Okay, so the distance of your LCG from hold number 7 and hold number 1, the LCG will be the distance of LCG. Okay, so let's go to the problem. By the way, guys, this is the formula for shifting of weights. Change of trim times MTC times 100, which is a constant, over the distance it moves. So this is the distance it will going to move from number 7 to going to number 1. So this is the distance, the change of trim. So when you take out cargo in hold number 7 and place it in hold number 1, so there will be a change of trim. Okay, and that's it. MTC, which is given in the draft, and this is the given the hydrostatic table due to your present draft, and this is constant of 100. So let's proceed to the problem. So while making a loading plan for your vessel, you obtain a draft forward of 12.93 and up of 13.23. To make your plan, so meaning you are trimmed by the stern because you have a bigger draft here at up and light draft in 12.93 in forward. To make your plan even keel, how much cargo are you going to shift from hold number 7 to hold number 1? Meaning from this drop you want to make it even keel. So it says find the main draft forward and up. So let's say by this take this, say 10. Example, maybe this is 11. Okay, so we will put entry and forward drop. How much is the forward drop? Forward drop says 12.93. So we put here 12.93. Forward drop is 12.90. 12.90. Okay. And take note of the up drop. Up drop is 13.29. So 13.29. Put here 13.29.29. So you will have, let's see, am I correct? Double check. 12.93. I'm sorry. 12.93. 12.93. Okay. Then 13. 13.29. Okay, 13.29 up. Okay, that's it. So you will have present main drop is 13.11, which is this one. And you have a trim of 0.36 centimeters or 0.36 meters. Meaning to say, your vessel at present condition, you are trimmed by the stern. So you have a trim of 36 centimeters or 0.6 meters, 0.36 meters. So you are trimmed by the stern. But it says how much cargo would you ship from number 7 going to number 1, so you will have an even keel. So even keel would be like this. So when you ship cargo from number 7, put it to number 1, so you will have an even keel condition. So how much cargo would you ship? So how much weight would you ship to have an even keel like this? Okay, so once you have taken out this min drop, we have to find out how much you have your MTC and LCF. Why? Because according to the formula, you're going to use this MTC. So you have to take out MTC from this min drop. Okay? So how do we do that? So you go to your min drop, which is 13.11. Okay? So you go down. Okay. 13.11. So you go to your draft or hide. You go to your hydrostatic tables. So here you have you can take out this one and take out this one. So your mid drop is 13.11, or your main drop is 13.11. So you are required to have your MTC. So what is your MTC? MTC is 13.11. Your MTC is 980 metric tons. So MTC here is 980. That will be run up of 980 because it's 79.97. That will be almost 980. Okay, so Is that correct? And the LCF, where do you take this LCF from? This one, okay? So you take out the LCF. Oh, I'm sorry. LCF from 13.11, you will have an LCF of 0.20. From this mid-drop of 13.11, you have 0.20. So your LTC is 0. Okay. So the next, I'll go back again to this our program. Okay. Go back to our program. Make it a little bit bigger. So you have an LCF here of 0.20 and NTC of 9.79.97. Okay. Now we take out this first so that will be clear. Okay. Now I want take note of this one. Since this is only your actual draft, you go down your vessel, you take out your forward draft, forward and up. Take your draft forward and up. That will be port and starboard. Forward, port and starboard, you have draft forward of 12.93, and up, port and starboard, you have a draft of 13.29. So you will have to take note also of you have take reading of your actual reading of your midship. Mean draft will be you have to add forward and up divide by 2, then you will have your mean draft. But your mid draft will be your actual draft. Meaning to say you have to go down at berth and make a reading of your mid port. Let's say your mid port reading is 13.11 and your mid starboard is 13.11. So your actual reading mid starboard, mid port, mid drop will be 13.11. Okay. Take out this first. Okay. So you have a reading of 13.11. Okay. Now you have a trim of 36 centimeters. Okay. You have a trim of 36 centimeters. Now you want to make it even keel, so you have to shift your cargo from number 7 to number 1. And how much would you ship your cargo? How much cargo we are going to ship? Then that will be computed by this formula. Cargo to weight, the weight of cargo to ship will be by this formula. But before we go that, we go to number 3. So in getting the distance from LCG of number 7 and LCG of hold number 1, this is the formula. So you get the LCG of your number 7, which is 66.32, and hold number 1 LCG will be 86.98. So where can we find this LCG? Okay, we'll try to check it out here. LCG of LCG of number 7 is 66. Hold number 7 is 66.32. Check. 66.32. And LCG of number 1, LCG of number 1 is negative 8698, okay, which is 86.98, which is this one, and number 7 is 66.32, which is this one. So number 8 is negative 86.98. Number 1 is negative 86.98. So you add these two values. So when you add that one, you have a distance of 153 meters. Okay? I'll show you the distance. It is the distance from hold number 7 center of the weight. This is the distance going down to hold number 1 at the center. Okay, so that will be your total distance of 153. Okay, now to find the change of trim, because you have a trim of initial trim of 36 and you have to make it even keel, so that will be 36 centimeters. Okay, so by way of figure, from a trim of 36 centimeters and you want to make it even keel, so you have a total of 36 centimeters. Okay, that will be your change of trim from trim by the stern going to even keel. So that will be 36 centimeters. Why? Because your trim is 36 centimeters. Okay, then how to find the weight? Find the weight to shift. So how much weight would you shift to number 1? Meaning, how much weight would you shift from hold number 7 to number 1? So you have to know the weight here. So this is the formula: change of trim times MTC times 100 over the distance of the LCG, or how much the distance you move from 7 to hold number 1. Okay, so this is the formula. So change of trim, which is 36 centimeters, and MTC, which is this one, 80.0, and the constant of 100 over the distance of 153. Okay, so the answer is 230.1 metric tons. So 230 metric tons you have to ship from hold number 7 to number 1. So this is the solution and this is the answer to your query. Okay, so let's see the program. Okay, by the way, just take note of this. Take note of this midship drop. Okay. Okay. So it says we have to ship hold number 7 of negative 230 metric tons. If you put that, so take out 230 metric tons from number 7, how much would the drop be? The drop would be, not if you have a trim of 20 centimeters, if you take out 230 centimeters from meters from hold number 7, because you want to shift this to number 1. We will try to, let's say, for the sake of computation, we try to put shift here to 225. Okay, just to show you the actual operation of a program. So you put from here, you put 225, and how much will be your draft? So you have a trim, exact trim, exact. You have now an even kill because your trim is 0. But let's say for the sake of computation, we put 230. 230 exactly. So 0 if on register. So we'll say 200, 226, 226. Okay, 2026. Okay, 226. So you're now even kill. So zero, the trim now is 0. Okay, so okay, so you you have to shift from hold number 5. It's either 230 or 226. But if you put 226, you will still have an even kill of draft of 13.11. Okay, as required. Since your final draft will be 13.11 forward and up, which is even kill, which is also the same as your min drop. So your final drop will be also be 13.11. 13.11. That will be your final mid, will actual mid. Okay, put there 13.11. So because you will have a zero sink of rice, your your final mid and your min train will be the same. Okay, this is your min drop, this is your mid drop. Okay, why I'm emphasizing this one? Because you will see the result of your deflection. So your mid drop will be this one. Mid drop, mid drop will be this one, and your min drop, which is this one, will be this one, min drop. So you have a deflection of 0. So from here you will notice your deflection. Okay, so you will have an even kill or 0 trim. What am I emphasizing here is that you have to get your actual mid drop, port and starboard, to get your mid drop, so that you can see your deflection or how much is your deflection. Because in your initial drop, which is forward of 12.93 and your up of 13.29, you have a mean drop of 13.11. Okay, so meaning what I'm trying to say, once you have shifting your cargoes from number 7 to hold number 1, you will have a final draft of 13.11 even kill of your final draft. Okay, so it is important that once you have this final draft, mid draft, which is your actual reading, you put it here, then you will have a deflection. Okay, so that's it, guys. From our review the calculation. Okay, I repeat, I will. So you have here the formula of how much weight you have to ship, the change of trim, which is 36, and the MTC and 100, which is constant over the distance of between holds, the LCG or between holds. Okay, this one going to this one. So this is the distance. Then you take the initial drop forward and up drop, and divided by 2, you have a mean drop, and you have a trim of 36. Now from this mean drop, you take out the MTC and the LCF, which is this one. So from here, you get your LTC 13.11 mean drop. You have MTC of 9.80 and LCF of 0.20. So you interpolate then from this your mid drop or mean drop. I mean mean drop. So from there, once you get your MTC and LCF, you measure now the distance. So you have an LCG of hold number 7 is 66.32, and your LCG of hold number 1 is negative 0.68. Okay, from these figures, yung LCG number 1 is negative 86.98, and LCG of number 7 is 66.32, which is this one. Number 1 is negative 86.98, and number 7 is 66.32, which is this one. Okay, so from these figures, you add this one, you have a distance of 1.53. Okay, and you have a trim of, find the change of trim. It's very easy because from trim of 36, you want to make it even keel, so you have a 36 centimeters of change of trim. So from knowing the weight from this formula, change of trim, which is 36, and metric the MTC is 980.0, and you times constant 100 over 153 the distance, so you have 230 metric tons of weight for shifting from hold number 7 to hold number 1. Okay, and that will be this one. From number 7, you put it to hold number 1. But if you put, for example, hold 2 to 5 for the sake of computation, you will still have the same amount. Why? Because in order to have a change of trim, in order to have a change or to move the vessel, you have at least you have 64 tons for 1 centimeter to sink or rise. So there's a lot of amount here, but you only have how much? You have only 4 tons. So it doesn't matter. whether you put here 27, 227, it will still be the same 13.11. Even if you put here 228, it will also be the same 211. See, but since you required only 230, you put 239 for the sake of computation. So we will still have this figure, okay? And here you have a 0, 0 deflection, okay? That will be more accurate. If you put, take out 230 here, put 229, and you have a deflection of this one. So that's it, guys. That's it. So hope you like this presentation and video. Please like, share, and subscribe. Thank you very much.